Hey boys and girls, it's Miss Pfeiffer, and today we're going to be doing equivalent fractions. So the word equivalent means equal, so we're going to be looking at fractions that are equal. How can fractions be used to represent numbers and their parts? This is a problem of the day, just kind of a review of skills we've learned, like our math for today. A movie theater has 1,325 seats. During the first movie of the day, 876 seats were taken. During the second movie, 53 seats were not taken. How many people attended the first or second movie that day? Okay, so if they attended, that means the seat was taken. So I know that during the first movie, 876 seats were taken. But during the second movie, it says not taken. So I have to figure out how many were taken during the second movie. So I'm going to go use this 1,325 and subtract 53 to get my answer. 1,325 minus 53. This will be how many seats were taken, because in my word problem it said 53 seats were not taken. So I know I have to find how many were taken. 5 minus 3 is 2. 2 minus 5. I cannot do that, so I need to go to my hundreds place. I take 100, that makes that 200. 100 makes 10 tens, so then I give 10 tens to that 2, so 10 plus 2 is 12. 12 minus 5 is 7. So 1,272 seats were taken during the second movie. So now I need to find out how many people attended the first movie. Well, that was 876. So if 876 and 1,272 attended the movies, I need to add or subtract. Good, I need to add those. So I'm going to add 876. 2 plus 6 is 8. 7 plus 7 is 14. So I'm going to put my 4, my tens, and take my 10 to my hundreds. 1 plus 2 is 3, plus 8 more is 11. Put my 1 and my 1. 1 plus 1 is 2. So 2,148 attended the movie. Now, there are 8 objects in Claire's backpack. Half of the objects are books. Right, so I'm going to draw this out because Miss Pfeiffer always works better with pictures. So I'm going to just do 8 circles. 1, 2, 3. It's hard to draw on this. 4, 5, 6, 7, 8. And if half were books, so I'm going to mark out half of them. Half of 8 is 4, because 8 divided by 2, remember half is like 2, would equal 4. So these were books, 1, 2, 3, 4. 2 of the objects are pencils, so I'm going to do a different color since those are pencils. 1, 2. The rest of the objects are folders. How many folders are in Claire's backpack? Well, I have 2 objects left in my drawing, so I would have 2 folders. Okay, now for the lesson. What do you notice about equivalent fractions? So equivalent fractions, I want to see what equals 1 whole. So if I get 1 whole, I know 1/2 and 1/2 equal a whole. So 2 halves equal a whole. Well, what about 1/2? I'm going to try fourths. 1, 2. 2 fourths equal a half, because if I line them up, it makes the same. And then I could do 1/8, 1 2, 3, 4. So 4/8 equals 1/2, or 2/8 equals 1/4. So I am noticing something. I'm noticing 1 whole, which is 1/1, equals 2 halves, or 1/4 equals 2/8, or 1/2 equals 2/4. Now let me look at this one, this third and the sixth. So 1/3 equals 1, 2, 6. Oops. So then if I write that out, 1/3 equals 2, 6. So I notice every time I'm multiplying by something. So 1 times 2 is 2. 4 times 2 is 8. 1 times 2 is 2. 2 times 2 is 4. 1 times 2 is 2. 1 times 2 is 2. 1 times 2 is 2. 3 times 2 is 6. So to find an equivalent fraction each time, I'm doubling it. I'm multiplying by 2. So I've kind of noticed a pattern there. Let's look on this page. After family dinner, the following fractions of a pie remain. Use fraction tiles to find the equivalent fractions. So if I use the rule I found, we're multiplying by 2. So 1 times 2 is 2. 2 times 2 is 4. So 1/2 equals 2/4. So I'm going to go back and make sure. 1/2, did 1/2 equal 2/4? Yep. Okay. So now I'm looking at 2/3 time, and I'm going to think about my rule times 2. 3 times 2 is 6, so 2 times 2 would be 4. 2/3 equals 4/6. So I'm going to come back and get my fraction tiles. I'm going to get my third. 2/3. And I'm going to get my sixth. Let's see if 4/6 works. These are hard to put exact because we're on the computer, but 2/3 equals 4/6. That did work. Right, so then my 3/4 times 2. 4 times 2 is 8. 3 times 2 is 6. 6/8. So I know that I can multiply by 2 to help me find equivalent fractions or equal fractions, because equivalent means the same as equal. Now let's try this one on our own. David is building a shed with 4 walls. Okay, so I know that my denominator is going to be 4 because that's how many walls there are. He constructs 2 of the walls, so he builds 2 walls. He builds 2/4 of the walls. Write 4 equivalent fractions to show the fraction of walls. So if I have a picture and he built 2 of the walls. Well, I know I can multiply by 2. So I know that 2 times 2 is 4. 4 times 2 is 8, so 4/8. Or I can multiply that one by 2. And 4 times 2 is 8. 8 times 2 is 16. But there's also another one I want to show you. So if he had 4 walls and he made 2 of them, I'm going to go backwards for this next one. And I'm going to do one on this side. If I multiplied by 2 this way, going up, what's the opposite of multiplication? Good, it's division. So to go backwards, I can divide by 2. So 2 divided by 2 is 1. Oops, I missed my first. Should put that division sign the other way. I can divide by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So 1/2. So 1/2 equals 2/4. So that would also be an equivalent fraction. So to get it to go backwards, to go down, I can divide. To go up, I can multiply. This next one. Noah has 1/2 of a fruit pizza. Noah could cut the pizza into smaller equal-sized pieces and still have half of the whole pizza. So he has 1/2 of the pizza, and if he cut it into smaller pieces, he could still eat half of the pizza if he ate 2/4 of the pizza. So 1/2 and 2/4 are equal. So 1/2 equals 2/4. They are equal. They were equal fractions, and the same as equal fractions means equivalent. Equivalent. This 5 can't fit that whole word. So 1/2 and 2/4 are equivalent fractions. Noah could cut the half of the pizza into even smaller equal-sized pieces. So use 1/8 fraction tiles to equal the length of 1/2. So if I have 1/8 and this is 1/2 of the pizza, how many fraction tiles? 8 fraction tiles equals 1/2. 1, 2, 3, 4. 4/8. So 1/2 equals 2/4 equals 4/8. Those are all equivalent fractions. So I could say I ate 1/2 of the pizza, I ate 4/8 of the pizza, or I ate 2/4 of the pizza. That would all be the same. Quan's bookshelf has 3 shelves. Only one of his shelves has books. Quan says 1/3 of the shelves have books. His mom says 2/6 of the shelves have books. Are they both correct? So I'm going to look here. This is what Quan says. 1/3 has books. This is what his mom said. 2/6 have books. Are those equal? Yes, they're equivalent. So they both would be correct. This is another way to use number lines. You can use a number line to find equivalent fractions. So 1/3 of one whole shares the same point as 2/6. They are both correct. So 1/3 equals 2/6. So they are, this 5 going to start typing this. They are equivalent fractions because they're at the same point. Complete the number sentence with an equivalent fraction. 1/2 equals 2/4. I can see right here I have 2/4. What pattern do you see in the equivalent fractions? 1/2, 2/4, 4/8. We talked about that. They're getting bigger, and they're getting bigger because they are multiplying by 2. They're getting bigger by 2. Or if you went this, so if you go this way, they're getting bigger by 2. But if you go this way, they're getting smaller by 2. You're dividing by 2. Complete each number sentence to show equivalent fractions. So 1/2 can equal 3. 1/2 has 1, 2, 3, 6. So right here, I would put 3. 1/2 equals 3/6. If I look at these pizza pies, 3/4 equals 1, 2, 3, 4, 5, 6/8. So here we go 3/4 equals 6/8. So on this one, so my pattern here was multiplying by 2 and dividing by 2. But on this one, it had a different pattern. Did it multiply by 2? Or did it use a different pattern? So 2 times 2 is 4. So did that one work for that denominator? Nope. So this pattern, I'm thinking, is multiplied by 3, because 2 times 3 equals 6, and 1 times 3 equals 3. So that pattern was multiplied by 3. This pattern, again, 4 times what equals 8? 4 times 2. This pattern was times 2 again, equals 8. And 3 times 2 equals 6. So I can do it by looking for the pattern, looking for the multiplication fact, or using the pictures. Did I skip one? Yeah. Alright, now here I see it on the number line. Complete each number sentence to show equivalent fractions. So I'm going to find 2/4 on my number line right here. And what is at the same point? So that would be 4/8 is at the same point. 4/8. And what is this number pattern? What is it multiplying? This is multiplying by 2. Right now I'm going to use these fraction tiles to help me with this one. 1/3 is the same as 1, 2, 6. So this would be 2, 6. What is this pattern? 3 times 2 is 6. So this one is also multiplying by 2. And 1 times 2 is 2. Match each pair of equivalent fractions. Draw a line to show equivalent fractions. Okay, so I have to figure out what equals 2/3. 2/8. 1, 2, 3, 4, 6. Or 1, 2, 3, 4, 8. I'm thinking that it's going to be 4, 6. So multiply my 2. Then 1, 2, 3, 4, 5, 6 eighths. 6 eighths. I don't quite see one for 6 eighths. I'm going to go to 1/2. 1/2. 2 eighths, that equals 1/4. And 2/4 equals 1/2. It can't be 1/8. So that is going to be 4/8. 1/2 equals 4/8. Then 6/8 can't equal 2/8. So 6/8, I think this one got messed up. So we're going to find out what could equal 6/8. Think what could equal 6/8. Not 1/8. We're going to change 1, 2, 3, 6, 8. We are going to write the equivalent fractions of 6/8. That would be, I'm going to get smaller. So if I divide by 2, that would be 6/8 divided by 2. So 6 divided by 2 is what? 6 divided by 2 is 3. And 8 divided by 2 is 4. So 6/8 is the same as 3/4. 3/4. This one is not correct. Okay, number 10. Raheem was at bat 8 times during a baseball game. He struck out 2 times. Circle the equivalent fractions that represent the number of times Raheem hit the ball. So I'm going to draw. He was at bat 8 times. 3, 4, 5, 6, 7, 8. Now remember, Miss Pfeiffer always likes to draw pictures. It always helps her no matter what the word problem. He struck out 2 times. And then this is how many times he hit the ball. So he hit the ball 6 times. So I know he hit the ball 6 out of 8 times. And now I have to find out what is an equivalent fraction to 6 out of 8. So I have to see if any of these other ones will work. So 6 out of 8. If I divide by 2 to make it smaller, because all of these numbers are smaller. 3, 1, and 2 is smaller. So I know I'm going to divide because all of these other numbers are smaller. 6 divided by 2 is 3. 8 divided by 2 is 4. Oh, 3/4. So I found my answer already. But I could also try and find a pattern. I could have done divided by 3. So 6 out of 8 divided by 3. 6 divided by 3 is 2. 8. Oh, I can't do 8 divided by 3. It doesn't work. So that would not have worked. So then I also can look at it. 8 and 8 have the same denominator. So can they be equal if they have the same denominator? No. So I know that one's not right. So my 2 answers are 6/8 and 3/4. Number 11. Leah said that it rained for 2 of the last 4 school days. So if I draw my picture, 4 school days, it rained for 2 of them. Circle the equivalent fractions that represent the number of days it rained. So I know it rained 2/4. And this one's a little easier to see. I also crossed out half of the circles. 2/4 is half of the circles. I can also use my test-taking strategies, and I know that 3/4 cannot be equal because they have the same denominator. 3/4 is not equal. And then I can look at this fraction, 4/2. Well, I know that's got to be even bigger than a whole because that 4 is bigger than the bottom number. 4/2 actually equals 2 wholes. 2 wholes, so I know that one can't work either. In number 12, Andrew had 8 math problems to do for homework. He completed half of them after school. So here's my 8, and if he completed half of them. So I want to do this bar. I want half of this bar. So 1, that's not half yet. 2, that's not half. 3, nope, because I have 3, and then I have 1, 2, 3, 4, 5. That's not half. 4. I have 4 on this side and 4 on that side. That's half. Shade the bar below to show the fraction of the problems he still has to do. So he still has to do 4/8 of his fractions, or he has to do 1/2 of his work. He still has to do 1/2 of his work and 4/8 of his work. Number 13, find the error. So I have to find what's wrong. Circle the fraction that does not belong with the other three. Ooh, so I can look at these and I can see that I think I'm going to do equivalent fractions. So I'm going to start with 1/2 because that's my smallest. So 1/2. And then I see, I'm looking at my denominators. I see 2, 8, 16, 4. So I'm thinking that I'm multiplying by 2 because I know when I count my 2's, it goes 2, 4, 6, 8, 12, 14, 16. So I'm going to multiply by 2 to find my next equivalent fraction. Because if I was multiplying by 3, I think it would go 2, 6, 18. So 1 times 2 is 2. 2 times 2 is 4. So I think 1/2 belongs. I don't see a 2/4. I'm going to keep going. I'm going to keep going with my pattern, multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. Do I see a 4/8? Yep. And I'm going to keep going with my pattern. I'm multiplying by 2. Remember, these are all equivalent fractions because I'm using the same pattern. 4 times 2 is 8. 8 times 2 is 16. Do I see an 8/16? Yep. So 3/4 is not an equivalent pattern. So I'm going to move that over here. And 3/4 is not equivalent. 3/4 is not equivalent because the pattern is multiplying by 2. Therefore, the equivalent fraction would be 2/4. Right, now this one. How do you know if two fractions are equivalent? Okay, so we know two fractions are equivalent. Two fractions are equivalent if they are the same size at the same point on the number line or use the same pattern, such as multiplying by 2. Right, now the next ones, 21, 22, and 23 are the ones you need to complete on your own. 21, slide 21 for number 1 and 2, you look at the pictures to fill in your numerator. Look at your pictures to fill in your numerator. Number 3 and 4, you're using the pictures again, but you're filling out the denominator. 4, you're doing the numerator and denominator. Number 5 and 6, you use these two circles over here and drag them to your equivalent fractions. There are two answers. There are two answers for both of these. Number 7 is write a definition for equivalent fractions, then give an example. Well, earlier in the slides, we talked about equivalent fractions. How do we know if fractions are equivalent? There's number 14 to help you with that one. Number 8, drag the circle to the correct answer, and you're finding which one is not equivalent. So which two do not work, which two do not follow a pattern. Hey, if you have any questions, please email or message your teacher. I hope y'all have a great day. We miss you.